All right, today we're going to be talking about solving systems of equations. We're going to use substitution and elimination. Let's just get started. We have two equations. We have two unknowns, x and y. Negative 9x minus 6y equals negative 24. Negative 3x plus 9y equals 3. We're going to solve for one of these variables here, and then we'll use that to substitute. So I'm going to solve for x, and this bottom one just seems like the easiest thing to do. You can solve for either one. So I solve for x, and I get x equals negative 1 plus 3y. We're going to use this, and we're going to plug this back into our top equation, and we will solve for y. So what we did was we plugged x, this is x, we replaced it with negative 1 plus 3y because those are the same values. That's what the equal sign means. It means the relationship between x and negative 1 plus 3y. The relationship is that they are the same thing. So we distribute negative 9. We have 9 minus 27y minus 6y equals negative 24. We combine like terms, and then we subtract 9 from each side. We get negative 33y equals negative 33. We solve for y by dividing both sides by negative 33. And we get y equals 1. We are going to take this value and replace it with the y there. We're going to substitute the value of y, which is 1, into this equation here. We substituted 1 in for y, and then we simplified the right side of our expression, or of our equation, and we get x equals 2. So our solution to this system of equations is the coordinate 2, 1. This is the point that both lines intersect. Now we have another two equation system with two variables. There's a common factor here, so what I'm going to do is I'm going to factor the 4 out of this, and we'll rewrite both equations. I did not actually change the value of x or y here. This equation is scaled by 4, so I divided by 4, and now it's the same exact equation, it just looks differently, but everything has the same value. So I'm just going to solve for y, because it seems easier to do that. So I get y equals x minus 5. I just added x to both sides. I'm going to take this value, x minus 5, and I'm going to replace it here, for y. This y is now just going to transform into x minus 5. So I color-coded it. It's in x minus 5 is in red because that equals y, just so you can see where it's been substituted. Distributed the 2, combined my like terms, solved for x. Then I'm going to take this value, and I'm going to replace it here, or I could even replace it here or here. It does not matter which equation we use. But I'm going to use this one because it seems the easiest. So as you see, I have negative 10. Because here I have a negative x. X already equals a negative 10. So I use parentheses to show that it's the opposite of my x value. So the opposite of negative 10 is 10. And I solve for y. Y equals negative 15. And so my final solution to this system of equations is the coordinate negative 10, negative 15. Now we're going to solve using elimination. I still have two equations. I have a system of two equations. There's two unknowns. But now I'm going to either multiply one of these by a constant, and then I'm going to add them together. We're going to do some labeling so we can keep track of what we're doing. I'm using the notation E sub 1, E sub 2, so a capital E with a subscript, to show you that this is equation 1 and this is equation 2. So I'm going to take the first equation, negative 6x plus minus 5y equals negative 10. I'm going to add it to negative 5 times the second equation. That's going to give me a new equation. So for clarity, that's negative 5 times x, because I started with x and e2, minus y, negative 5 times y, here, equals negative 5 times negative 13. That was from the second equation. So we plug in negative 5 for our x, then we solve for y. We get y equals 8. So our solution to this system is at the coordinate negative x, 8 is the solves both equations. First thing I'm going to do is I'm going to look between these two equations and see which variable is the easiest to get rid of using elimination. Why does it say substitution? That should say elimination. Sorry about that. Okay. And so it looks like I'm just going to multiply equation 2 by 3. And so let's do that. So you'll see here I have equation 2, but now it's been multiplied by 3. 15x plus 3y equals 33. I'm just going to add these two together, and it's going to cancel out the y. 33 minus 9 is 24. Solve for x. X equals 3. Oh, I guess I'm recording. I replaced x with its value, 3, so I have 5 times 3 plus y equals 11. Now I'm just going to solve for y. Final answer is 3, negative 4 is the point that solves both equations.